right, so we're going to go over the homework for 8-1. Just to remind you, or maybe tell you, this is chapter 8. So I got here by, like on my tab, like I had, so you have the welcome board here, and then off to the side, you know, you have these. I have a lot more that I see than you see. But if you go to chapter 8 and just click on chapter 8, there's the solutions. The only cool thing is and it's step-by-step work for every single problem. Huh? My philosophy in this, the reason why I share this with you, is because if you get stuck and you get the complete wrong answer, I'd like you to go and find out why, and maybe see, looking at this, and they give you nice, helpful hints what they do here. Like here, they show you that they took -3 times row 1 and added to row 2. So to look at it and see if that helps you learn. My idea for this is not so you go to this and just copy it, because that does you no good, that does me no good. Okay? So you want to go to that one? Was that 64? Yeah. Well, yeah. That's good to know. Now. So you wrote an augmented matrix, and when I go to write an augmented matrix, are you okay if I move this to row 1? Sure. And I'm going to do that because it has a coefficient of 1, and that's what I want. Oh yeah, I did see. Okay. So I'm going to do 1, -1, -4, 14. Then did you leave? What did you make row 2? I just left it. So you left -1, 1, 2. -10, and then you made this row 3. Okay, so that's right? So then what I'm going to do is, you probably added row 1 and row 2? Yes? So what I have here is I have this one. Then I want to make these 2 zeros. And I'm assuming I don't know the directions, but I can look at the directions. The directions just say solve, right? It says use Gaussian elimination with back substitution. So all I have to do is make this main diagonal for my coefficients 1, and then these 3 things zeros, and then I can back substitute. Yes? So so you added row 1 and row 2, yes? So I'm doing 1, -1, -4, 14, and then I'm doing -1, 1, 2, -10. And when I add these, I get 0, 0, -2, 4. That's why we're probably oh, because this kind of makes, if I divide this by 2, where I get 0, 0, or -2, 1, -2. So what? Okay. So yeah, once you get one thing wrong, you're done. I don't know how else to say. But if I were doing this, I would leave row 1 alone. And then since that turned out the way that turned out with the 2 zeros, I would just put that in row 3. Okay, and then I've already used, so I used row 1 and row 2 to make that happen. I have to somehow use row 3, and you're probably going to add it to a version of row 1. So you did -3, row 1. So I'm going to have -3, +3, +12, -3, -42. How do I do? Someone's talking to me. 3, -2, 1, 15, and we have 0, 1, 13. Oh my gosh, 7, 3, 27, negative. Huh? So then this is 0, 0, 1, 13, -27. So that turned out really nice, because I have this main diagonal once. I have all these as zeros, so now I can just do the back substituting. Yeah, I got the exact same thing except for my. Oh yeah, once you get, especially if you get that one wrong, you're done. You're gonna get them all wrong. Any other questions? So we're good with chapter 3.1? Good. Let's start from 2. All right, so just a reminder that your 126 SAT problems are due on Monday, October 10th, so not this Monday, the following Monday. If you have questions on how you keep tabs, just let me know. And then you will have a quiz on 8.1 through 8.3 next Thursday, which I believe is the 6th. It is the 6th. All right, so what we're going to do today is we're going to determine whether two matrices are equal. We're going to add and subtract matrices, multiply two matrices, new matrices to transform. No, we're not doing that. I got to cut that out. I was so happy when I got to cut that out. Yeah, no, we have to do that. We don't have to do that. And then we're going to use matrices to solve real life problems. And on these ones, when we do word prompts, I'm going to let you use your calculator for those. Okay? Yeah, I know. Shocking. All right, here we go. So represent a matrices. So we talked about this before. A matrices can be denoted by uppercase letters. So when I name a matrix, I'm going to call it like a capital A, capital B, capital C. When I go to talk about what's inside the matrix, those are called elements, and each element has a special like little coding system. So what this means is this is row 3, column 2. So I'm going to have a little A sub 3, 2. The first number tells you what row, the second number tells you what column. So kind of like Excel, right? Yes. All right, so we talked, so we know that, and so when I look at two matrices and I want them to be equal, the first thing that has to be true is they have to have the same dimension. If they're not the same size, they cannot be equal to each other. The second thing that has to happen is every element in the first matrix has to equal the same element in the second matrix. So this first row, first column has to equal first row, first column. Does that make sense? Second row, second column has to equal second row, second column. Okay? That's simple, right? So if in order to add, what I'm going to do is I'm going to add by this corresponding element. So row 1, column 1 has to be added to row 1, column 2. In order to add two matrices, they have to be the same order or the same size. And then when I go to add these, I'm just going to add 1 plus 0 and get 1. 5 plus 0 and get 5. Negative 3 plus 0 and get negative 3. This is not rocket science, right? So that would be negative 3. I'm running out of shapes. So that would be 6, and then finally 7, 1. So every corresponding element has to be added to the corresponding element. So this one, I'll give you a second to do these two. Everyone got that? Yes. And then the next one, what was your sum? Yeah, it's not possible. It's not possible because this first one is a 3 by 3, the second one is a 3 by 2. Since they are not the same size, you cannot add them. So you have an identity, oh, I shouldn't change this yet. So you have identity for addition. So what is the identity element for addition that you learned way back in my second grade? And when I say identity, addition identity, that means that if I add this number to any number, I will get the same number back. So what is the additive identity? 0. So if I add 0, I get the same number back. What's the multiplication identity? 1. So if I want to have an identity matrix for addition, it's going to be a matrix full of zeros. I don't know. You have to know that. So there you go. All right. So those are all the additive identities. Now we're going to talk about a scalar multiplication. A scalar multiplication is when you change the scale. So if you change the scale of anything, you have to be careful to multiply everything by the same number or divide everything by the same number. So in scalar multiplication, what you're going to do is you're going to take that scale, which is negative 3, and you're going to multiply by every element in A. So they're saying that this is a capital letter used to represent the matrix C. So I'm going to take negative 3 and I'm going to multiply it by everything in this matrix C. And when I do that, that's a 4. I'm going to get negative 12, positive 3, 0, negative 12, positive 9, negative 24. And that's what negative 3a would be. Not hard, right? If I asked you to do 2b, you would do the same thing. You would take 2 times every element in b. And when I do that, I'm going to get 0, 8, negative 2, 6, 2, and 14. And then sometimes you have this where you're asked to add those two. So I'm going to go down here to do this problem. I'm going to go down here and just add those two that I just figured out. And add the corresponding elements. Easy. Okay, properties and matrices. You can change the order that you add. That's commutative property. You can change the grouping. In other words, I can add B and C first, then add A, or I can add A and B first, then add C. If I am multiplying by a scalar, it does not matter where I put that scalar. It can be at the front or the back. And then this is just saying if I multiply by 1, it's staying the same. Commutative property or distributed property, if I'm multiplying by a scalar, I can multiply both matrices by that scalar, then add, or I can add first and then multiply by the scalar. And this is just saying the same thing. Here's the question though, what is not on here that should be on here? I'll tell you if I have the following, if I ask you to find A plus B plus C plus D, could you do it? So to find A plus B, you take 4 plus 0 plus negative 3 plus negative 3, add those all together, and you get negative 2, right? 1, 2, 1, 5, and you get 2, 0, negative 2, 2, and you get. This is not hard, right? I can do fast. Perform. So here I have this 1/2 out in front of these, subtracting these two matrices. When I subtract, you can either choose to add the negative or you can try and remember to add or try and remember to subtract. Does that make sense? Okay. Well, I could go through here, make this plus, and then make this negative 10, negative 5, negative 3, positive 6. Now I have a choice. I can add these two first. Well, according to the way it's written, it wants me to add these two first, then multiply by 1/2. The other alternative, which I would honestly never ever do, would be to distribute the 1/2 to all 8 things and then add. I don't know why anyone would do that, but that is an option. Are you guys done? I feel like you're waiting for me. Are you waiting for me? So negative 2, 8, negative 20, 12. How did okay. You tell me if I made a mistake, right? Now, when I have equation this where it says solve for x, this means that x is a matrix C. And I'm supposed to know that because the x is capitalized, which means I have to type it correctly on the test. So when I go to do these, I like to solve for x first. Like I like to solve for this x first over here, and then put the matrices in. Does that make sense? Instead of dealing with the matrices. So when I do this, if I was solving this, I would subtract a from both sides. So I'm going to have 3x is equal to b minus a. Everyone good? And then in matrix world, there really isn't division. Instead I'm going to have to multiply by something. So what would I multiply by? Yes. 1/3. So I'm going to say x is equal to 1/3, and then I'm going to have to be careful to put that b minus a in parentheses, because I know I have to distribute that 1/3 to both sets of matrices. Or I have to actually subtract and then multiply the 1/3. You good?
Good.
You need to come up here and do this? Okay. So here I'm going to say the matrix x is equal to 1/3, and then I have b, so I'm going to write that matrix C. And then subtract a. Now, I kind of like making this a plus and then shipping in a negative sign. Well, I wouldn't really do it to 0, but I did just to show you what I was doing. Because it's 6 times I have to remember to subtract. Does that make sense? And I might forget. Especially if I was sleeping. So here I'm going to go 1/3. And then we have -4, -8, 5. Is that a +1? -5. That's what I did. Check it. What would I do? Yeah, I would take this and take it all the way back up here to the original to make sure it works. I'm not asking you to check. I'm just telling you how to check. Good? Okay, matrix multiplication. There's that. Let's just do one. Ready? In order to do the product, you have to have, this is a 2 by 3. This is a 3 by 3. In order to multiply, this number of columns has to equal this number of rows. So when I write them next to each other, that's what I usually do. I write 2 by 3, 3 by 3. If those numbers match, that means I can do it. And then my answer will be the size of what's left over. So in this case, my answer will be a 2 by 3. To do matrix multiplication, I like writing myself notes. So I'm going to do I'm going to do row 1, column 1. So row 1, column 1. That's what I'm doing. So I'm going to take 0 times 1 plus 5 times 1 plus -3 times 11. You see how I got those numbers? Because that's the way you have to multiply. I know, it's not pretty. So I get 0 plus 5 plus -33, so -28, I believe. So if I were forming my answers in row 1, column 1, I would write -28. Yes.
Do you have to, like, if it's increase that first?
I have to multiply row 1 by every single column. I have to multiply row 2 by every single column. So, yeah. I'm going to highlight now. I like highlighting better. So if I highlight, I'm still sticking with row 1, but now I'm going to do column 2. Okay? So to do that, I'm doing row 1, column 2, and that's going to be 0 times -4 plus 5 times 2. And see how I'm writing all this beautiful work? You see this beautiful work I'm writing? On a test or a quiz, guess what I want to see? All this beautiful work, absolutely. So that's 18, that's 10, 28, I think. How do you do? Row 1, column 2, positive 28. I'm gonna stick with row 1. And now I'm gonna do row 1. Huh? Okay, do that. This is 0. This is 10. This is 18. And then finally, I'm still on row 1, and now I'm doing column 3. So I'm going to have 0 times 0, 5 times 2, negative 3 times 9, negative 17. Now, I've multiplied this row by every single column, right? So it should make sense to you that now I'm going to go down to this row and probably start all the way back to column 1. It is a lot. Who said that? I'd like to challenge you know what? Mental math. 5. And my answer matrix, where am I going to put that? Yeah, right below the negative 28. And that's why I write myself these notes, right? In case you get lost or confused. I forget what I was doing. Row 2, column 2. So I'm still sticking with row 2, but now I'm doing column 2. Line 6. I teach you how to check your answers. Six times 0. Well, that's nice. And 1 times 2. And then 0 times 2. And negative 2. Are we good? And then that does match the size that I was anticipating my answer to be. It's not bad. It's long, it's tedious. It's okay. No. So if I took like this one is a 2 by 2, this one is a 2 by 3. When I can multiply them, my answer is going to be a 2 by 3. It's really crazy if you take like a 1 by 4 and multiply it by a 4 by 1. It's going to be a 1 by 1. But if you took a 4 by 1 times a 1 by 4, it's going to be 4 by 4. Which should tell you what? What should I tell you? No, that's 3 by 2 times 2 by 8.
Oh.
It's going to be a 3 by 8. Yes? The middle, yes, the number of columns has to equal the number of rows. Not possible. Huh? Yeah, they're both square. But that doesn't always happen. So I see where you got that. That's why I made that guy.
Yeah, they're like opposite numbers, like they have their like 441 and then 4114.
Oh yeah. Then there's. Are you done with this one? Did you do that when we were having this little conversation? Huh? Alright, I'll give you a minute. Okay, so here are the answers to B, C, and D. Everyone good? Okay, if I want to find A squared is A times A, right? So, so if it's a square matrix, I can do it every single time. So I can take this 5, -2, 3, 1, and I can multiply it by 5, -2, 3, 1, and I will get an answer, yes? But if I had like, if I had this matrix that was a 3 by 2 and I wanted to square it, I would be trying to multiply it by another 3 by 2, and that would not be possible. Does that make sense? So just because you're squaring a matrix does not mean you can actually do it. Okay, I think you guys are good at multiplying. You think we can move on without actually doing this one? Perfect. Okay, so this one, if I want to solve a system, there's a way to do it with matrices and matrix multiplication. So they have it written as, they say consider this matrix, and they have the x1, x2. I'm going to rewrite that if you don't mind, because this is copied directly from the book. So if I write -x plus 3y is equal to 3, and then x minus y is equal to 3. I just replaced the subscripts with x and y. Does that make sense? So if I do this, if I'm doing this, when I do, if I put this into a matrix, this is -1, 3, 1, -1. That's my coefficient matrix. And if I multiply it by the variables x and y, I should get my answers 3 and 3. So this is a 2 by 2. This is a 2 by 1, so I know I can do it. My answer would be a 2 by 1. And the reason why this works is if I sit here and highlight this again, this is row 1 times column 1. I would say -1 times x, -1 times x, plus 3 times y is equal to my row 1 column 1, which is 3. So this is the -x plus 3y is equal to 3. You see how it works that way? You agree that I can write it like that. This is me just proving that I can write any system like this. So what I'm going to do is, for today, and just for today, we're going to write the matrix C. This is my coefficient, and then we're going to do the dots, and then this is B. So this is just saying I'm going to take -1, 3, 1, -1, put the dots, and my answers were 3 and 3. And then I'm going to use Gauss-Jordan elimination. Gauss-Jordan elimination means what? That's another word for what? Reduce row echelon form, which means my main diagonals have to be 1s. Everything else has to be 0s on the coefficient side. Does that make sense? So you can't do the back substituting. So this one is a baby one, yes? I think it's a baby one. If I'm doing Gauss-Jordan elimination, do you want to leave the matrix the way it's written? Are you good with that? What do you want to do? You can flip them. So if I decide to flip them, I'm going to flip them. So if I flip them, I'm going to put the 1, -1, 3 here. Why are you doing this? I agree. Why are you doing it? Yeah, he's just putting the positive 1 on the top left. Row 1, column 1 is a 1. Now, remember, so I have that 1. I want to make this a what? 0. So what am I going to do to make that a 0? Add the 2. So row 1 is not going to change. So I'm going to take row 1, and I'm going to add it to row 2. And when I do that, I get 0, 2, 6. What am I going to want to do at this point? Divide by 2. So when I go to write it in here, I'm going to write 0, 1, 3. Still have to put in reduced row echelon. What's the last thing I have to do? Add row 1 and row 2. So row 1 is 1, -1, 3. Row 2 is 0, 1, 3. When I add them together, I get 1, 0, 6. So 1, 0, 6, 0, 1, 3. So do we agree that this is my X column, this is my Y column? So X is equal to 6, Y is equal to 3, order pair 6, 3. If I wanted to check it, what could I do? Yes, I could put it back into the original equation and make sure it works to the original equation. Now, is that terrible? Okay, that was a baby 2 by 2. You know where it's going, right? I go right to the word problem? Oh, let's do the word problem. All right, so here I have a fruit grower raises 2 crops which are shipped to 3 different outlets. The list below shows how many units of each crop are to be shipped to each outlet. The profit per unit for crop 1 is $3.75. The profit per unit for crop 2 is $7. Find the profit for each of the 3 outlets. Any ideas? Well, this one isn't even a word problem. This is easy. Is it not easy? I think setting it up as a matrix actually makes this one harder. All right, so crop 1, you get $3.75. Yes. So this right now, the way it's written, if I just forget this and forget this, is written as a 2 by 3. Everyone agree? So I wrote that way too small. That's okay, I can write small. I want to multiply it by the prices, right? Which I'm going to put in the matrix. What size dimension? Oh, I only have 2 prices, right? 2 prices. So can I write this matrix like this? No. Why not? Because I only have 2 prices, so I can do a 2 by 1 for my prices, right? Right now, the way I wrote it, I can't multiply this. So what am I going to have to do with this matrix? I'm going to flip it, but how am I going to flip it? What does that mean? Can I do like 100, 125? Because now I'm doing outlet 1. Does that make sense? And then this will be outlet 2, outlet 3. I have to keep them together, right? 75, 150, and then 75 again, 100. So now I wrote this as a 3 by 2. I'm going to multiply it by my prices, which I'm going to write as a 2 by 1. We need 75 and $7. Just to make sure, and my answer is going to be what? A 3 by 1, which should be the outlets and the profit for each outlet, yes? And to do a double check, when I go to multiply this, I'm taking 100 times 375. Well, that's how much crop 1 is, right? You with me? And then I'm going to add that to 125 to $7, which is how much crop 2 is, and those are both from outlet 1. So the way I wrote my matrices makes sense. Does that make sense? Does they make sense? That sounds really weird. All right, so so for row 1, column 1, I'm going to take 100 times 375. I cannot mental math this. And then 125 times 7. And somebody nice is going to tell me the answer. And then I'm going to do, so that's row 1, column 1. I'm done with column 1, so now I'm going to do row 2, column 1. And that's going to be 75 times 375 plus 150 times 7. I have no idea. 13, what?
$1,330 for $1,331.45.
Yeah, I'm good. Calculator page, we'll get that into in a second. If you hit this button next to the 9, what's the button next to the 9? Button next to 9, I have this, which you guys showed me the episode, I knew it was in here. You have a bunch of matrices built in, right? You have a 2x2, a 1x2, a 2x1, and then you have this guy that looks like a 3x3. The 3x3 is the only one that is editable, so you can change the dimensions. So that's the one I'm probably going to use most of the time. When I do this, it asks me for the number of rows, number of columns. So if I go back to this problem, this was a 3x2, yes? So I'm doing 3x2, so that's going to stay the same. I'm going to change this to a 2. Oh, I hate it when it does that. I'm going to hit OK. And then I'm going to type in the numbers that I had for that. So this was, oh, it's not going to let me type it. 100, right? And then what was the next one?
127.
And then 75. And then what was the next one?
160.
And then 75 and 100. And I'm going to get out of that matricing. See how that had that long cursor thing? Then I'm going to hit times. And then multiply it by a 2x1, right? So I'm going to hit that same button I did before. Leave it. I could go to this one if I wanted to, or I can leave this without. You care which one I do? I'm going to this one. I'll be perfectly honest, I sit here. I just stay here. 2. Oh, I might not, because it's not working for me. 2x1, hit OK, and it was $3.75, and the other price was $7. Hit enter, and it multiplies for me. Okay? So 981.25. So if I wrote this as a matrix, I know that this is the units is cash or money, but what is 1250? What does that represent? It's $1,250 what? American money, yes, American money. But more importantly, it's the profit from where? Yeah, so this is, you gotta know what you're doing. So this is the profit from outlet 1. This is the profit from outlet 2. This is the profit from outlet 3. Okay? And what? Alright, so here's your homework for tonight that you're doing for Monday. Still working on the SAT over the weekend. You don't want to leave all those problems till next Sunday, right? And then you have a quiz on Thursday. I'm writing that down for those. Quiz 8-1 to 8-3 Thursday. Yeah, I'm saying 8-3. I wonder, yeah, I think I can do that. I think I can make that happen. I'm making that happen. Okay, any other questions?